Hello students, in this video we will derive and understand the integrated rate law expression for a first order reaction step by step. So let's get started. So let's consider a simple reaction, that is reactant R gets converted to the product P. So we know that for a first order reaction, the rate of the reaction depends on the first power of the concentration of the reactant. That is, the rate law will be rate is equal to proportionality constant into the concentration of the reactant R to the power 1. So this will be the rate law expression for this equation. Okay, now let's write the rate expression for this equation. So what will be the rate expression for this equation? It will be equal to negative for the reactant because the concentration of the reactant decreases while the product of the reactant increases, right? So it will be d of R by dt with respect to time. Again, we are equating it with the product. So product will be positive. So d of concentration of P by dt. So this will be the rate expression for this equation. Okay, children, as both are rate, the rate law also rate expression. For the rate expression also we got rate, right? So let's consider this one to be the first equation. Let's consider this to be the second equation. As these both are R rate, we are going to equate. We are going to equate both the equation. So what we will get by equating? K into concentration of R to the power 1 equal to minus dr by dt equal to plus d of P by dt. So you see, children, we have like three equations, right? Like three things are equated here. But this is the main thing where we have a rate law. If you see here, you can't do anything with this. Both equations have same terms, that is R and R. But in this term, if you see, there is a P term. We can't do anything with that, right? So we are not considering it. So that we are just removing them. So the only equation then we will be equating to find the integrated rate law for this expression will be, we just have to equate these two things. Okay. Now let's rearrange this equation to separate variables. Here we have two variables, that is R and dt, right? So we are rearranging the variables. So we will be getting it like, I am just taking this, what I'm going to do is, I am taking this dt this side while this R will be coming this side, okay? So it will be k dt is equal to minus d concentration of R by R. It is in the multiplication, so it comes here as a division. Okay, what we have to do now is, now we have to integrate both the sides. So integrating both sides. So by integrating the both side, we will get k dt is equal to dr by r. So this negative sign here, to make it a positive thing, I am multiplying both sides by negative. So what will happen? I am just taking this negative here. Got it? Okay. Now let's simplify this by using a log rule. So there is formula where integral of dx by x is equal to ln of x, okay, and also dx, integral of dx will be x. Always remember this integral formula, students. It will be really helpful for to derive other integrated expressions. Okay, students. Now by using this formula, we are going to integrate it. Okay. Integral of dr by r will be equal to ln r is equal to minus k. Here k is the constant, so we have to take it out of the integral symbol. So integral of dt will be t plus of I. So it is the integral constant. So whenever we are integrating, we have to add the integral constant. Okay. So now we got this expression. Let's take this as a equation 4. Okay. Now what we have to do is, student, to find the value of this I. So to find this value, we have to substitute t is equal to 0. That is, the reaction is not at all starting. The reaction is not proceeding. The time is 0 here. Okay. So if the t is 0, the reactant will be at 0. Okay. It will be R naught. This is known as initial concentration. Okay, students, now we are going to substitute this t value and the r value in this equation 4. If we substitute it, we will be getting ln r naught is equal to minus k, t will be 0 plus I. So we will get, so this value will get cancelled because it's 0. So from this we obtain I is equal to ln r naught. So now we got the I value. What we are going to do is, we are going to substitute this I value in equation 4. Okay, we are going to substitute this I value in this equation 4. So what we will get then? Ln r is equal to minus kt plus ln r naught. Okay, so a little thing to keep it in mind before we proceed to the derivation, that is, this equation looks similar to the y is equal to mx plus c. Okay, the y will be this, c constant will be this, and the x here is similar to this t here, and the m here is similar to this minus k. Okay, just keep this in mind. Okay, now let's proceed. So what I'm going to do now is, I'm going to take this ln r naught to the other side. So what I will be getting? Ln r minus ln r naught is equal to minus kt. So to remove the minus kt, what I'm going to do is, I'm going to multiply both sides with minus. So what I will get? Kt is equal to ln r naught minus ln r. Got it, students? So what happens? One thing you see here is we have a formula to write this equation. We can further simplify it. That is, keep in mind, ln A minus ln B will be equal to ln A by B. Got it? Keep this in mind. Okay. So by substituting this value, by using this formula, we will get Kt is equal to ln R naught by R. Now I'm going to take this t to the other side, so I'll get K is equal to ln R naught by R. So I will get 1 by 3. Okay. So here we have another conversion, that is this ln can be ln, can be converted to log. So the conversion is ln is equal to 2.303 log. So by substituting this value, we will be getting K is equal to 2.303 by T log R naught by R. So students, this end equation is the integrated rate equation for the first order reaction.
So from this what we understood, students, the rate of the first order reaction depends on the initial concentration of the reactant. Okay.
Now let's plot a graph between ln R and T. So now let's consider this reaction, I mean this equation from the previous sum. Also we have taken this equation. Okay, we are just taking the same equation. This equation only I have written here. Okay, in this we see, as I've said already, this will be compared to the y is equal to mx plus c equation, where the y-axis will be ln r and the x-axis will be t time. Okay, and the slope m will be equal to minus k. So the m is minus k, which it means it is a negative slope, right? So as it is a negative slope, that's the reason the graph is declining. And the intercept here represents the ln R naught. Okay, this is the ln R naught. Hope you understood this graph. Now let's move on to the next one. Okay, now let's draw a graph for the log R naught by R versus T. Here also we are going to use the same expression. So as we have already compared this equation with y is equal to mx plus c. Okay, as we need here log R naught by R, what you are going to do is we are taking this ln R naught to this side. So it will be ln R minus ln R naught is equal to minus kt. So as we have seen in the previous formula, we can simplify it further by dividing it, right? We have a formula, right? So R by R. Okay, I will repeat it again. So there's a formula, very important. Anything to the ln A minus B. Ln A minus ln B will be equal to ln A by B. The same formula we are using here also. Okay, by using this formula, we are substituting these values. So this will be equal to minus kt. So here is the minus. I am just taking it to the other side. So what will happen? Kt will be equal to ln. It will inverse, right? So R naught by R. So when we compare this to the equation y is equal to mx plus e, this will be the y, right? Because we are checking this as the y axis. Then y is equal to, this will be the mx. So your x is the t and m is the k. And plus c should be there, right? But here there is no c. That means c value will be 0. So that's the reason the intercept value is 0. It is starting from the origin. Here also, as the slope is equal to the positive value k, it is a positive slope. So that's the reason the graph is like this. Okay, students? I hope you understood the derivation clearly and also how to plot this graph, and watch my rate law video for a clear understanding. The link is given in the description, and if you found this video helpful, don't forget to like, share and subscribe to Chemexcel with Nithi. See you in the next video. Thank you.